Okay, this video is just going to cover a few different problems just to help us out and just so that you guys have seen some problems done. This is an example of an overlapping event. Okay, overlapping event. And what it's saying is that a library has 463 science books. It has 592 fiction books. And then there's 37 science fiction books. So these 37 books could be considered in either of these categories. Okay? So when we ask what's the number of science and fiction books, when we count these numbers up, we got to make sure we don't count this amount twice. So what we're going to do is we're going to say that there is 463, let's do that in orange, 463 science books plus 592 fiction books, and then we're going to minus the overlapping event. So we're going to subtract out this 37 science fiction books. From here, it's all calculator work. So we're going to be looking at 463 plus 592 minus 37. And the number of science and fiction books that are available at this library would be 1,018. Okay, so here's just another example of an overlapping event. Okay, this is dealing with permutations of letters within a word. So if we take this, we'll just consider this as two words, maybe put a hyphen here. We'll just consider sad panda, okay? When we take a permutation of this, how many different ways can we arrange it? Well, how many digits are there? There's 1, 2, 3, 4, 5, 6, 7, 8. So 8 digits, so we can make different words with 1, 2, 3, 4, 5, 6, 7, 8 spots here, okay? However, this is a little different from when we were doing it in the last video. The reason for this is, check out, there are 3 A's, okay? 3 A's. There's also 2 D's. And let's see, those are the only repeating letters. When we have repeating letters, what we need to do is we need to divide by those letters factorial. Okay, so here we would say there's 8 spots, so 1, 2, 3, 4, 5, 6, 7, 8. We'll say the different ways we can arrange this is going to be 8 factorial divided by how many repeats are there? Well, there's 3 A's and 2 D's. Okay, so when we have repeating letters, what we have to do is we have to divide by how many times it repeats factorial. Okay, and notice we have 2 different repeating letters, so A and D, so we're going to divide by 3 and 2 factorial. Okay, this is kind of an expected value problem. Okay, so we're going to say that there's a 0.8 chance or a 0.8 probability that I'm going to buy a milkshake, and a milkshake costs $4. There's a 0.4 chance that I'm going to get pie, which is going to cost me $3.50. Okay, let's say that I'm only going to buy one, though. No, I'm sorry. Let's say that I am going to buy one, but that Ari is going to buy the other. Okay, what is going to be my expected value that I pay? So there's 2 ways to look at this, okay? There's one, if I'm going to buy the milkshake, let's say I am going to buy the milkshake, then there's a 0.8 chance that I buy the milkshake, okay? And that's going to cost me $4. This is going to be added to the chance that I don't buy the pie, okay? So this is going to be our negative. So this will be our, what's our chance of not buying the pie? Well, it's 0.6, which is going to be minus 350. No, because excuse me. This is the minus because I'm buying this, okay? And it's a 0.6 chance that Ari is going to buy the $3.51. But there's also another situation, and we have to check both, is that there's the 0.2 chance that I don't buy the milkshake, okay? And then there's a 0.4 chance that I do buy the pie. Okay, so there's two different equations. There's one with the probability that I am going to buy it plus the probability that I don't. Okay, so don't get caught in the fact that I've given you a probability. You got to be thinking that what's the probability that I'm not going to get the milkshake, that Ari's going to get it, and that's a 0.6. Okay, going on the other side, what's the chance that I don't get the milkshake? It's going to be 0.2, not 0.8. 0.8 is the chance that I do get it, and then it's going to be 0.4 times the amount that I'm going to spend. Okay, so there's two different equations, and what we're going to do is we're going to get answers to both of these. So 0.8 times 4 is 3.2. So this is negative 3.2. Okay, and then we have 0.6 times 350 is 2.1. So on this one, I'm only going to be losing, let's see, 3.2 minus 2.1. Oh, that was silly. Oop, and I plussed it. Okay, this is going to be negative 1.1. And then on the other side, I have 0.2 times 4 is 80 cents. If you guys can see that, here, I'll twist it. And then we have 0.4 times 3.5 is negative 1.4. On this one, 0.8 plus negative, no, 1.4 minus 0.8 equals, this is negative 0.6. So which one am I spending less money? It's going to be this guy. So I want the situation in which Ari's going to buy my, or I'm going to buy my pie, and Ari's going to buy my milkshake, because the expected value here is that I will only lose 0.6 compared to losing a 1.1.
Okay, last problem I want to go over is number 13 from page 648. And it says you have a 6-letter permutation for the word nimble. What is the probability that? This probability, this means that it's going to be this over the sample space. So the first thing we want to do is, since it's talking about probability, is we want to find out what our sample space is. So for the 6-letter word of nimble, we have 1, 2, 3, 4, 5, 6. How many choices of letters can go in here? Well, it's 6. How many more choices do we have here? 5. How many choices here? 4, 3, 2, and 1. What does this equal? Well, this is just 6 factorial, which I need to go get a calculator for. Okay, this came out to 720. So our sample space here is going to be 720. Then we get into more specific questions, such as the third letter is an I and the last letter is a B. So let's go 1, 2, 3, 4, 5, 6. Well, how many I's are in the word nimble? Well, only one, and it has to be the third letter. So we only have one choice for the third position. The last letter has to be a B. How many B's do we have to choose from nimble? Just one. So we're going to put just one in that position. Then how many letters are left remaining that we haven't used yet? Well, there's 4. How many letters can go in here? There's 3. How many choices are left for here? 2. And at that point, there's only 1 left here. So what we have here is 4 times 3 times 2 times 1. Oh, no. 4 times 3 times 1 times 2 times 1 times 1 is 24. This equals 24. However, we're looking for probability. So we want the probability of how this, or how many times this will happen. 24 is how many ways it can happen, but the probability of it happening is 24 out of 720 choices. So 24 divided by 720 is 0.0333 repeating, or we can think of this as 3.3%.
Okay, let's do one more just to really lock this in, okay? This time we want the second letter to be a vowel and the third letter to be a consonant. 4, 5, 6. Okay, so the second letter is a vowel. Well, how many vowels are in a nimble? There's 2. So we have 2 choices for the second letter. And then the third has to be a consonant. Well, how many consonants do we have to choose from? 1, 2, 3, 4. So we can come to our third and say that we have 4 choices here. Now we have to realize how many choices do we have left for the first position. Well, we've used 2 out of the 6. So we have 4 more choices that can go here. And then over here we have 3, 2, and 1. So let's multiply this. This is 4 times 2 times 4 times 3 times 2 times 1 is 192. So there's 192 ways in which we can have a second letter as the vowel and a third letter as the consonant. However, we want this as a probability. So we're going to say 192 divided by 720. 20 or 0.2666 repeating, or we can think of this as 26.6%. Okay. Hopefully these problems helped you out, and good luck on the quest tomorrow.